Hi guys, for a warm-up, let's go ahead and just answer, pause the video when I'm done giving the question and answer this question for me. Would a triangle that has a side 3, 9, and 15, would that actually be a triangle? Okay, pause the video, answer the question. And so it definitely would not be it would not form a triangle because the triangle inequality states that any two sides have to add up to be greater than the third side, the greatest side. So when you add 9 plus 3, you get 12, and 12 is definitely not greater than 15. So therefore, these three side lengths would not, in fact, form a triangle. So now what I want us to do is let's look at the problem that we have now. So let's say we had a side of a triangle 6 and another side of a triangle 10. What could, or the range of the third side be? For instance, we know that this could be 11 because if you made this side 11, 6 plus 10 is definitely greater than 11. But when we have a missing third side, we want to kind of know there's actually a range. There's a couple things. It doesn't just have to be 11. So the way we set up this problem is we could call our missing side x. And based on the triangle inequality theorem, we know that 6 plus 10 has to be greater than x, whatever x is. But we also know, whatever x is, let's say x wasn't the largest side, let's say x was the middle side. Well, we also know that 6 plus whatever x is also has to be greater than this side right here, which would be 10. And the last one we actually don't really have to put down because if you have 10 plus anything, it's definitely going to be greater than 6. So we don't really even need this one. Well, if you solve each of these, 6 plus 10 is greater than x, which means 16 is greater than x. If we flip that around, that would mean x has to be less than 16. Because if it was greater than 16, then these two sides would not add up to be greater than it. So x has to definitely be less than 16. But also, because x doesn't just have to be the biggest side, if you solve this inequality, you minus 6, you get x has to also be greater than 4. Well, if x has to be greater than 4, but also less than 16, that gives us a range. We write that. We learned last year in algebra. You can say that x is between, but not including, 4 and 16. So x could be 7, x could be 15, x could be 14.4, 14 and 4 tenths, x could be 10. But this gives you a range for all the things x could be. Now let's try one on our own. Okay, I'm going to put a problem on, and then as soon as I'm done, I want you to pause the video and then try to solve it on your own. Let's say we had a side 2 and a side 15. What could the third side of the triangle be? All right, pause the video, and then you could play it once you're done. All right, so here's how the solution. We're going to call this missing side x. So we know that 2 plus whatever x is has to be greater than 15. We also know that 2 plus 15, any two sides have to be greater than the third side, would have to be greater than x. And the one that we really don't need to mention is 15 plus x is greater than 2, because of course anything plus 15 will be greater than 2, because it's a side of a triangle, and it can't be negative. So if you solve this one, you get x is greater than, if I subtract 2 on both sides, 13. And if you solve this one, you get 17 is greater than x, which if you turn that around, that would mean that x is less than 17. So our range is that x is between 13 and 17. So x could be any number between, but not including 13, all the way up to 17, but not including 17.